Hello friends, welcome to follow up. In this video, let's look at problem 1522, diameter of N Ary tree. This video is a follow-up video for problem 543. So as extensions, you can also see problem 208 and problem 3045 after this video. So these two problems, problem 208 and 3045 are related to try. So try actually is an N Ary tree, right? That's why after you see this video, you can try to implement a try data structure, right? Using the similar notations here, and then you can do an application of try in problem 3045. With this part of information shared, let's come back to the problem itself. So here we are given a root of an N Ary tree. We need to compute the length of the diameter of the tree. So here the diameter of an N Ary tree is the longest path between any two nodes in the tree. And this path may or may not pass through the root, right? So here for this example, in example 1, so here we can, the output is 3. So one path is 5, 3, 1, 2, right? But this path corresponding to the diameter is not unique. So you can also see the path 6, 3, 1, 2 is also valid, right? So basically this is also special in the sense that this longest path corresponding to a diameter length passing through the whole tree root. Well, in example 2, so the diameter is 4, right? So there's 4 red marks. And the path actually corresponds is 5, 3, 2, 4, 6. It does not pass the root for the whole tree. Well, it passed the root for the left subtree, rooted and true. So in example 3, you see there's the diameter is the 7, right? The red marked ones corresponding to the path, but this path also passing through the root of the whole tree. So actually, these 3 examples are very representative. It's more representative than problem 543 because it demonstrates that the path needn't pass the whole tree root, and also example 3 can help us indicate the general situation. So with that said, let's also look at the constraint. This is also important, right? The depth of the N Ary tree is less than or equal to 1000, right? So the total number of nodes is in between 1 and 10 to the power 4. So actually the second item basically restricts the problem size because the total number upper bound is 10 to the power 4 for the nodes. So with that said, let's look at the sort. So actually we did a video before. This is some annotations from the previous video, but it's not very precise. So here we represent one solution, but we give 2 formats. So this will make the problem more clear. So basically, I want to get 2 pieces of information for each node. Let's call this tree node U, because we are going to do traversal. We want to do this, retrieve this information in a recursive fashion. For each tree node U, you can think of this 1 or this 3 or the 2 here, right? So we get 2 pieces of information. The first is the number of nodes in the path from U to the deepest leaf in the tree, inclusive. For example, if you look at this one, so the deepest number of nodes in the path from U to deepest leaf for this 1 will be 1, 3, 5 or 1, 3, 6. The number will be 3. In other words, D of 1 will be 3. Then PU is the number of nodes in the longest possible path, including the one passing through U. So here you notice the wording, so including, right? So this may be a set operation, but here I can first write in. So include the one passing. So I do not use include. Let's see. I guess include. So I first replace it So see, in the one passing through U in the original full tree, I just consider the path, very path passing through this node itself. And in other words, I don't consider subtrees. So then in this case, the recursion relation is very simple, right? So here, assume U is a root and they have some children, say V0, V1, and Vn. So for example, for this one, they have children 3, 2, 4. And the most representative one is 3, right? For this root, they have subtrees 2, 3, 4, 5, right? And then let's assume if we do a recursive call, we can get the corresponding 2 pieces information for each of the subtrees or the children. So we have dvi and pvi, right, for all these trees. Then for the generic case, for the du, we can get the information, right? So what's the deepest one from the root u to the deepest leaf? For sure, we need to find the dvi, the largest one, then plus the root itself, right? For example, if you compute the result for 3, then you will get the deepest path will 3, 7, 11, 4, 14, this is the 4. And then for this root 1, it will be 5, right? 1, 3, 7, 11, 14 is the deepest one. And then assume that the largest two deepest leaf node has number dv0 and d1. So here, for example, for this one, the two longest one is 1, 3, 7, 11, 14. Or you can choose this 1, 4, 8, 12. If you like, you can also replace the second one with 1, 5, 9, 13. Because these two, they have the same number of nodes, or in other words, the same length from root to leaf, either from to 12 or 13. And then if I use in here, I need to change this p of u to be d, let's use v0 plus d v1, the two longest one, plus 1, right? So some people may argue, so what if you don't have two branches, right? Like here in this example, right? You just have one branch. So you will see how we treat that. Notice that. Let's put a placeholder. What if you have 0, say less than 2 children or subtree, right? So the answer is that we do this right in the list, right? Then we just retrieve the first 2 elements after we sort, and then we retrieve 2 for our list. Then if it has just a 0 or 1 element, you will get 0 or 1. So this is a very simple trick. So this recursion relation is corresponding to in, right? I just consider the root itself. And then this one, I also consider all the possible largest paths passing through the children's. This corresponds to include, right? So notice the difference in the wording or in the meaning. Actually, this is a very subtle or delicate details. If you could understand this in a very clear fashion, it demonstrates that you understand the very in a very clear or deep fashion for the problem. If you have doubts or difficulty in understanding the two variants, you can review the 2 version v2 solutions for leetcode problem 543. So with that said, and then let's look at the coding. So here we need to use sort to get the dv0 and dv1, right? So here I wrote some extensions like leetcode 543. This is the routine. And also we implement try abstract data structure using N Ary Tree, right? So this exactly this problem 208, and also the application for 3045. So with that said, let's look at the coding. So I want to do this one first. So notice the interpretation, right? So including here. And then I want to distinguish and then using this one again, right? So here first, I'm going to, let's see, I'll write this one as v1. So we want to use include, right? So for this one, first I'm going to write a hyperfunction, right? So I'm going to call this function f, right? Just you know, this is the traversal function, right? So first, if not root, I'm going to return 0, 0. So this is the for sure natural. And then let's look at the general information. As we mentioned, I want to get these two pieces of information for the possible children. So basically, we want to do f node. So for node in root children, right? Notice that children is a dictionary, or you can see this is recursively defined. You can regard it as list. Actually, we can use dictionary, but here is use list. It's okay. So f node for node in children, right? If node. So let's add some filter so that we don't consider null case. So for example here, right? So with that done, now let's get the information for first one. So let's see if not info. So in other words, this node actually is a leaf node, right? There's no children at all. So in other words, this is the empty one. So in this case, we just need to return 1, 1, right? In other words, this 1 corresponds to the root node itself, right? And otherwise, so we have the length of this info. Let me write some detail. So the m is actually at least 1, right? But it can be 1. In other words, less than 2. But still, as we mentioned here, we have a placeholder. What if you have less than 2 children? But I just want to use this to get the right. So let's do a sort. First, I'm going to introduce sortage. So notice that here I didn't sort in place, right? Just to demonstrate the purpose. So here we get info I. So I want to sort the first field, right? For I in range M, right? So here I want to see, because I want to find get the deepest one. So I want to reverse equals true. So this way, the first element in the list temp corresponds to the first piece of information. In other words, deepest root to leaf path. This information is a number nodes, right? So I'm going to set info 1 to be 1 plus temp 0. So this temp 0 is a deepest root to leaf path, or the number nodes in that path. It corresponds to a subtree. But then we add 1. This 1 corresponds to the root itself, right? This is the first part of information. So here I want to write using include. So notice the second information. So the info 2. So I want to first, I want to do this. So info I. So I do this sort for I in range M, right? And then what I'm going to do is I update this info 2 to be either max info 2. In this case, I consider the all the deepest paths passing through the subchildrens, right? For example, here this corresponding to passing this one is corresponding to 6, 3, 7, 11, 14. This will be 5 nodes. And well, for this 4, right? So just have one tree. So it's 12, 8, 4. This will be 3. And for this 5, it will be 4, right? For this 2, it's just 1. And then also I want to get 1 plus the longest 2, right? For example, this is the 1, and then plus the longest 2. It will be sum of temp longest 2. For this example, we are adding actually this sum that is 4 plus 3, that's 7, plus this 1, that will be 8. Well, for this other parts, it corresponds to 1 and 5 and 3 and 4. Overall, the largest one is 8, right? And then what I'm going to do, I'm going to return info 1 and info 2. So that's the first version. So now let's call this function and then get the result. So first I get the result. So I'm going to call this function f. So get root. And then what I'm going to return is result minus 1. Because the result basically demonstrates the number of nodes in the pass corresponding to parameter. So here -1 is computes the length, right? So here let's write if result is greater than 1, is greater than 0. So in other words, this result -1 will be at least 0. Otherwise, we return 0, right? So then let's do a test quickly. Yeah, it passes the example 1 here, I guess. Now let's look at the generic case. Yeah, it passed all the cases. So this corresponds to if we interpret this PU as the number of nodes in the longest possible path, include the one passing through U and downwards subtrees, right? So now if I want to write a solution that is only concerning this U itself, it might be more natural. So this is also not hard, right? So let me copy this one. So what I'm going to do is this. So I'm going to try this one as version v1. And then what I'm going to do is, so it's actually all comes to this part. So here I did a max for this piece of information, right? So actually I can comment this out. I don't need this part. And also I don't want to take maximum among the other roots. But I only consider each time I look at one node, I just consider the longest path passing through that node. So for example, here, if I look at 1, and I just want to focus on return 4, not considering, see, this is 3, this is 1, this is 1, do maximum. So for this example, say you have 1, so you just return 4 because it has no right branch. So the longest left branch will be 4. Right, so here I don't need this. I just need to get this. Also, this automatically treat this question. What if you have less than 2 children, right? So, but we cannot do directly like this. So what we want to do actually is to let me add a result attribute to the class, right? So this if you do this, and you can understand that, so this is a class attribute, or you can see each instance. So I'm going to set it to be 0. And then each time I get this information for the current node, then what did I do? What should we do? We do this, self, we do max, the previous state of result, and then the current information. So this way, we actually put this maximum comparison and in here. In other words, we use this attribute to update the possible parameter length. So here, notice that here we store the number of nodes in a possible path. So then let's call this function, right? Call this one, and then we do this self result. If self result is greater than 0, otherwise we return 0. So this will be another format. So I guess this will corresponding to in. So let's call it v2. It will be in, right? In this interpretation here, and this corresponding to this recursive relation. So let's do a quick test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic cases. So actually, in parallel to in problem, say 443, so we can use non-local variable. So here, I'm going to call this one version v2, right? So here we use attribute because this is not very good in some sense, because we want to bound just to this solution itself. So here what we do, so here is let's see, v1, let's mark this one as v2, and then we do here. So this one, so this one we use the class attribute, or we use the field. So here I want to use a non-local variable. So this is actually very easy. You set this one here without the self. So notice that this result is assigned a integer, so it's immutable, right? So if we want to update this one, we need to non-local this variable, and then we do some adjustment. The adjustment is here. So it result and result, and here result and result. So now let's do a test. So let me first check. Yeah, we are checking this one, right? Because here the function signature had changed. So let's look at this one. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So basically, that's about it for the two variants of solutions. I would say here is one solution, but with some slight variant. But it's crucial in some sense to understand the difference of the two related but different interpretations when we write recursive solutions. So if you can absorb or grasp the main idea for these two problems, that is problem 543 and the current problem, so you are encouraged to look at problems 208 and problem 3045. So maybe tomorrow or so I will going to share some explanation for those two problems, right? So with that said, I guess that's it for the current video. Thank you for watching.